You are probably using AI as a manual loop right now. You ask a question, wait for an output, spot a mistake, copy it, paste it back in, and ask for a fix. You are the one driving the cycle. For the past few years, the entire focus of the industry has been on packing as much instruction as possible into a single, massive block of text. But relying on a single prompt to execute complex work has hit a hard performance ceiling. The models break down when the task requires multiple distinct steps and real-world feedback. The most advanced AI users have stopped trying to write the perfect prompt. Instead, they are designing systems where the model receives a goal, inspects its current state, takes an action, checks its own work, and decides what to do next. To understand how to build systems that actually do the work for you, we need to break down the architectural frameworks powering the next generation of AI. So hit subscribe and let's look under the hood. A standard language model is completely blind to the outside world. It generates text based on probabilities, but it has no inherent way to verify if the code it just wrote actually compiles, or if the research it summarized is actually accurate. To turn that passive text generator into a working agent, its architecture has to change. It must move from a linear, single-turn sequence into a continuous, self-correcting cycle. An AI loop closes that cycle. It operates as a closed state machine moving through 5 specific phases: planning a move, acting on it, observing the result, evaluating success, and revising the next step. To construct this, the architecture relies on the Planner-Executor Pattern, separating strategic thinking from physical actions. The planner takes your broad objective and breaks it down. It evaluates tools like a web search or a code terminal and maps out the sequence to solve the problem. Then the executor takes over. It takes that planned sequence and runs the selected tool in the external environment, triggering an API call. This schematic shows an actual execution loop for the Planner-Executor Pattern. It outlines exactly how the system passes a selected tool and its parameters to the executor, checks if the outcome was successful, and if not, triggers a local recovery plan to try again. But there is a massive flaw if we stop here. Language models are inherently stateless. If the model instantly forgets the result of the tool it just ran, it will try the exact same failing command over and over again. Action without memory leads directly to infinite recursion. To prevent the system from getting stuck, the architecture requires a structural mechanism to hold state. That mechanism is working memory. It acts as an active scratchpad, catching the messy, raw outputs returned by the external tools, so the agent has a record of what it just attempted. You cannot simply dump a massive, unsummarized error log back into a language model's context window. Doing that overwhelms the model's attention mechanism, causing it to lose focus on the original goal. The scratchpad cleans and summarizes those observations first. With a clean record of what happened, the loop must decide if the action was successful. But if you ask a language model to grade its own output, it will pass itself. It is a very generous marker of its own homework. To solve this, developers use the Reasoner-Critic Framework. This pattern introduces a secondary logic gate to handle the evaluation. The critic is an unforgiving, deterministic gate. Instead of relying on the AI's opinion of its work, the critic uses hard validation, like a compiler test, a strict data schema, or a linter. If the output doesn't match the exact criteria, it fails. When the critic fails the output, the exact reasons for that failure are extracted and fed backward into the planner. This forces the language model to acknowledge the specific error and generate a new plan. An AI loop without an independent evaluator is just an expensive way to generate confident mistakes. True autonomous course correction only happens when a generative model is constrained by a deterministic evaluator. Even with perfect evaluation and memory, a fully functioning loop carries a significant operational risk. It can execute its steps flawlessly, yet run indefinitely without ever achieving success, burning through server time and API limits. A loop that cannot stop is a liability. Engineers prevent runaway costs by hard-coding stop conditions, strict rules like maximum iteration caps, hard token budgets, or mandatory human approvals before the next cycle begins. This hybrid approach, combining AI reasoning with strict human-coded pathways, is known as an agentic workflow. Right now, it is the exact architectural pattern dominating successful enterprise deployments. There is a myth that the future of work belongs to fully autonomous software operating with zero oversight. But the reality of production-grade AI is highly structured workflows, where the language model provides the reasoning and human-defined guardrails provide the safety and repeatability. The model itself is just a component. The true intelligence of modern AI lies entirely in the system architecture designed around it.